Hello everyone, it's Mr. Kissinger at the Citizenship Academy in Syracuse, New York. This is 5th grade math module 4, lesson 9. Today we're going to be learning how to multiply mixed numbers. So I'm going to start by doing a little bit of quick review here. It says changing a mixed number to an improper fraction, and I'm going to show you guys a trick to quickly changing mixed numbers into improper fractions. We know that 8 can be changed into fifths by we know that 1 whole is 5/5, and we can multiply 5/5 times 8 to find how much 8 is in fifths. But since our numerator and our denominator will be the same when a fraction is equivalent to 1, if we multiply our whole number and our mixed number by our denominator, we'll end up with our numerator. So I'm going to put a little time sign in here between 8 and 5. And this equals 40. And then I need to add the 4/5 that I already have. And I'm going to get my mixed number here. 40 plus 4 is 44, and we have fifths. So I multiply my whole number by my denominator, and then I add my numerator, and that will give me my mixed fraction. Now, if it's easier to you to multiply 5/5 times 8 and then add your fraction, your 4/5, you can certainly do that as well, and you'll end up with the same mixed number. You'll end up with 44/5. But it's going to be important when we're multiplying mixed numbers that we turn our mixed numbers into improper fractions first before we start to multiply, or it's not going to work. So next we have to change an improper fraction to a mixed number. So when we get our product, we're going to want to change that back into a mixed number. And you can do this a number of different ways, but I do like the way that EngageNY York shows this. We kind of turn this into a division problem because remember, fractions are division. So if I want to divide 16 by 7, I just do this. 16 by 7. And 7 can't go into 1, but it can go into 16. It goes in there twice. So I know my first number is going to be 2. I subtract 14, and I have 2 left over. I'm going to leave that as a fraction, so I'll make that 2/7. So it's going to end up being 2 and 2/7. Now, if we wanted to quickly look at this, we can go, if I see that, hey, I know that 14/7 is 2, because 7/7 is 1. 14/7 is double 7/7, that'll be 2, so I could take 14/7. I know 16/7 would be 14/7 plus 2/7, and I know 14/7 is 2, so that will be, this becomes 2 plus 2/7, which will give me 2 and 2/7 as well. So again, whatever way makes the most sense to you. I do like to use division if I'm unsure, just to make sure that I'm dividing properly when I'm finding my whole number and my mixed number. But moving on here, it says when we multiply fractions, we do not need a common denominator or a like denominator. We don't, when we're adding and subtracting, remember we need to find a common denominator for the two fractions that we're subtracting or we're adding. But when we multiply fractions, we don't need a common denominator because we're going to multiply the numerator and the denominator, the numerator by the numerator and the denominator by the denominator. So this one says draw a model for the following problem. I guess this is still part of our review portion here. And I'm going to use an area model for this. We'll draw an area model just like this. And I have 1/2 halves, and I'm going to make fourths here. And I have 1/2 shaded, and I have 3/4 shaded. I guess I should probably use my colors here to make it a little easier to see. So I'll make this part blue, and this part will be red here. And the part that has both blue and red in it will be my product, and that will be 3/8, because I have 8 pieces all together there, and I have 3 of them shaded here. So this will be 3/8. Again, look, if we look, 1 times 3 is 3, 2 times 4 is 8. So we don't need to find those like denominators or common denominators. We're just going to multiply straight across when we multiply fractions. Now, what is the difference with this problem right here? The difference is we have a mixed number involved. We no longer have two just regular fractions. We're going to have a mixed number. So there, I'm just going to say there is a mixed number. Being multiplied. Okay, so let's get started on the problem set here. It says we must rewrite mixed numbers as improper fractions first. So we went over how to turn a mixed number into an improper fraction. So this first one here, we had 2 1/5. The 1/3 we can leave alone. That one's not a mixed number. But to turn 2 1/5 into an improper fraction, we're going to multiply 2 times 5, and that's going to give us 10. And then we're going to add 10 plus 1, and that will give us 11. 11/5. Now we have 11/5 times 1/3. We have 11 times 1 is 11. 5 times 3 is 15. Number 2, we have 1 4/7, and we have we're multiplying by 1/2. 1 4/7 is equal to, well, 7 times 1 is 7, plus 4 is 11. So this is going to be 11/7. 11/7 times 1/2 equals, well, 11 times 1 is 11. 7 times 2 is 14. So we'll have 11/14. So the first one we had 11/15, and then number 2 we had 11/14. So we haven't had an improper fraction as a solution yet, where we've had to turn the improper fraction back into a mixed number. Maybe we'll see that on one of the other problems here. So number 3, 2 5/6 times 2/3. 2 5/6. We'll have to turn that into an improper fraction. 6 times 2 is 12, plus 5 is 15. Oh, 17, not 15. So this will be 17 sixths. Again, 6 times 2, this is 12. Sometimes I might just write this up here, 12, and then plus, plus 5 will give me 17. If that helps you to write the product of 2 and 6 up here before you add to your numerator, you can certainly do that every time. And then I have 17 sixths times 2 thirds. 17 times 2 will give me 34. And 6 times 3 will give me 18. And look, we do have an improper fraction here. So really quickly, I'm going to look and see, okay, 18, I can take 18 away from 34 and make it 18 eighteenths. And then I can subtract 34 minus 18 and I have my remainder. But can I put 2 18s into 34? So I'm thinking about my division problem without writing it out in long division. But if that becomes too hard to do in your head, again, we can just go right back to our long division. So we'll do 34 divided by 18. When in doubt, I always try to write it out. And 18 won't go into 3. 18 will go into 34. The question is, will it go in once or will it go in twice? And if we think about our multiples of 18, well, 18 times 1 would be 18. 18 times 2 is 36. So 36 is greater than 34, so it won't go in twice. It's only going to go in once. So we'll have 18, then we subtract, and we have to borrow. 14 minus 8 is 6. 2 minus 1 is 1. And we have 1 and 16 eighteenths. And I could even simplify that a little further because I can divide my numerator and my denominator both by 2. So I could divide my 16 up here, my numerator, by 2, and I would get 8. And I would make sure I put my 1 in there for my mixed number. 1 and 8, and then I divide my denominator by 2 down here, and I get 9. So 1 and 8 ninths. And 1 and 16 eighteenths would be acceptable as well. It didn't ask us to simplify, but it's nice to get in the habit of simplifying because you may be asked to do so at some point. Our next problem here, it says 1 and 3/4 times 4 sevenths. So 1 and 3/4 turned into a mixed number. Well, I need to do 4 times 1 is 4, plus 3 is 7. So, and that makes sense because 1 would be 4/4. 4/4 plus 3/4 is 7/4. 7/4 times 4 sevenths. Well, this will be an interesting one because we're going to have 7 times 4 is 28, and 4 times 7 is 28. And we're going to have 28 28ths, and 28 28ths is 1. So our answer here is going to be 1. 4 sevenths of 1 and 3/4 is just 1 whole. Kind of neat how that worked out. All right, let's do 1 or 2 more here. We'll do, let's start with this number 5. So we have 3 and 1/6. 3 and 1/6 equals 6 times 3 is 18 plus 1 is 19. So it'll be 19 sixths. 19 sixths times 4 fifths equals, well, we have to do 19 times 4 on the top here. And I'm gonna write that one out. 9 times 4 is 36. 1 times 4 is 4, plus 3 is 7. So we have 76 on the top. We have 30 on the bottom, 76 30ths. So I might simplify that first and then make it back into a mixed number, because that might be a little bit easier for me than dividing those bigger numbers. So I know I can divide both of these by 2. They're both even numbers. And then I'll end up with 76 would be 38 is half of 76. And I have 15 on the bottom. So 38 fifteenths. I'm going to write that up here as my solution, my product, but I need to turn this back into a mixed number. So 38 fifteenths, well, I know 15 times 2 is 30, so I have 2, that'll be 30 fifteenths, and then I have 8 fifteenths left over. I did that kind of quickly. I could have used my long division, but since I know that 15 times 15 is, or 15 plus 15, or 15 times 2 is 30, I know that'll give me 2 wholes, and then I have an extra 8 fifteenths left over when I take away those 30 out of the numerator. All right, and we'll do one more. We'll do one that has 2 mixed numbers in it, because that'll be a little bit more challenging here. 2 2/3 equals, well, 3 times 2 is 6, plus 2 is 8. We have 8/3 times, and then I have actually, let's do these separately. 2 2/3 is 8/3, 1 and 5, 6. Well, 6 times 1 is 6, plus 5 is 11. That equals 11 6. 11 sixths. Now I need to take my 8/3 and multiply it by 11 sixths. 8 times 11 is 88. 6 times 3 is 18. So I have 88 eighteenths. I can divide both of these by 2. They're both even numbers. So I'll get a simplified version of my fraction here. I have 44 ninths. Half of 88 is 44, and half of 18 is 9. So divide 88 by 2 and divide 18 by 2 to get my simplified fraction. I have 44 ninths. And then we'll turn that back into a mixed number. So we have, I know my nines will be 9, 18, 27, 36, 45. Oh, 45 is more than 44. So I can only go to 36, which is 9 times 4. So my whole number will be 4. And I will have 8 ninths left over. 44 minus 36 will give me 8. So I'll have 4 and 8 ninths. All right, so we're going to wrap it up there for today. Hopefully this gives you some good strategies to use to multiply fractions that involve mixed numbers. Thank you guys so much for tuning in, and look forward to seeing you next time.